Decades now, we've been saying we should reduce our emissions, but they've kept increasing. One of the key reasons is we don't measure accurately the climate impact of our actions. Imagine trying to save money, but when you go shopping, there is no price tag on any item. Or trying to lose weight, but you cannot measure the portion sizes and the calories. You would be bound to fail. This level of blindness is close to the one we have when it comes to our climate impact. Measuring greenhouse gas emissions is hard. It has no color, it has no smell, it's invisible. We cannot put sensors everywhere. On every building, every truck, every field, every cow. So most of the time we give up and we don't measure. And when we do measure, we are reduced to relying on estimations and conversion factors. The consequence is we end up working with highly incomplete and inaccurate estimations of our emissions, often with a margin of error of 30 to 60%. This means targets and action plans are set based on inaccurate data. If we look at the corporations that report their progress on climate to the CDP, which is a non-profit organization that runs a global disclosure system for environmental impacts. What we see is striking. More than 2/3 of the companies are not accurately measuring their emissions. And only 7% of those companies are ultimately reducing their impact in some way. You cannot reduce what you cannot measure. It is key for corporations to be able to measure across all activities, all sources that drive carbon up or down, in a way that's just putting the same rigor to carbon measurement than the one we have for financial accounting. It took more than 100 years to put modern, automated financial accounting in place. We don't have 100 years when it comes to climate. But this is crucial for corporations to set meaningful targets and successful action plans. One of the most powerful tools we have to help us accelerate on this journey is artificial intelligence. Artificial intelligence can process data automatically from diverse unstructured sources like invoices, consumer behavior data. It can work by modeling to better estimate the missing information. It can simulate and ultimately optimize emissions. Let me share an example of how this could work. A wine and spirits international company, billions of sales, hundreds of brands, consumers across the globe. When they want to measure their impact, they need to measure across the entire set of their emissions. This means direct emissions from facilities, purchased electricity, raw materials, leased assets, IT emissions, business travel, transportation, waste, product end of life, etc., etc. That's a huge amount of information to collect. And most of it is actually inaccessible to the company itself, because it comes from outside its direct scope of activity. For example, from suppliers that are not yet able to calculate their emissions either. So, when the sustainability team calculates their impact, they have no choice but to do rough estimates. Let's zoom on the glass for bottles. The way they calculate glass emissions is the following. They take the total amount of glass bought last year, let's say 1,000 tons. They multiply it by a conversion factor, which represents the average kilos of CO2 equivalent for 1 ton of glass. Let's say 950. 950 times 1,000 makes 950,000. Of course, this is hugely inaccurate because it does not take into account all the numerous factors that impact actual emissions. So it's hard to set targets and action plans. This is where the sustainability team calls data scientists to come in and process detailed data about the type of glass, the color of the glass, the recycling share, the supplier country of origin, the transportation mode, by brand, by product. They can